Hello and welcome to Virtual Investor Conferences. My name is Bob Power, and on behalf of OTC Markets, we're very pleased you've joined us for our next live presentation from Li-Metal Corporation. Before I introduce our speaker, a few points to note. Please submit your questions in the question box to the left of the slides. If you're interested in meeting with Li-Metal, please click on the Schedule Meetings tab found in the platform navigation bar. You'll be able to view the company's availability and submit a meeting request. On a final note, all of today's presentations will be recorded and available for 24/7 replay. At this point, I'm very pleased to welcome Kunal Pfalfer, president of Li-Metal, which trades on the OTCQB venture market under the symbol LIMFF and on the CSE under the symbol LIM. Welcome, Kunal.
Great. Thanks, Bob, and thanks everyone for joining. I've been introduced by Bob, so I'll just get right into it. So Li-Metal was formed in 2018 with this mission to look at technologies that are critical for next generation batteries. So what we mean by that is anything successive to lithium ion. So it's really a presentation. I'll talk about where we are in terms of those technologies and where we're headed in the medium term. But diving deeper, really we're focused on the anode side of the battery supply chain. Graphite anodes have been used in lithium-ion batteries for some time. There's new technologies like lithium metal anodes that can replace the graphite anode and provide a lot of performance benefits. And so we're looking at a vertically integrated approach with our technology to, one, create lithium metal in a different way, and that different way is using carbonate as a feedstock, and two, produce the anode so that you can really get the type of anodes, which is really ultra thin anodes, using a vapor deposition process. And these are technologies I'll go into further, and they're both scalable technologies that have leveraged existing technology platforms like molten salt electrolysis or PVD to adopt them for this purpose. So as I said, we're focused on these two pieces, which I'll go into. Just some quick facts. Founded in 2018, we're about 30 people. We've raised close to $40 million Canadian, several patent applications in the pipeline for both technologies, and again, really focused on the next generation value chain. So the value chain, it's not being built now, but the value chain being built for the end of the decade. In terms of team, a majority of us either come from the battery supply chain or lithium supply chain, including in our board. I should mention we didn't update it yet in the presentation, but this morning we announced a CEO transition. Maciej is our current CEO. He's also a co-founder of the company. He'll be moving into the CTO role, which wasn't previously had in the company, but he was effectively doing. And a gentleman, Dr. Srini Godavarti, who's going to join as CEO, who previously worked at Albemarle in their lithium metal business and has several years of experience in various battery materials. So just some highlights. It's only been not even a year since we listed on the OTC. We actually listed the company on the CSE the year before in late 21. Since then, we've commissioned several facilities to continue to develop our lithium metal and our anode technologies. More recently, though, to advance, we've executed a term sheet, which I'll dive into deeper with Mustang Vacuum Systems that supplies PVD machines, so the vapor deposition machine that I was talking about. And our goal is to really continue to build partnerships and continue to develop our lithium metal production going forward. Just to highlight this partnership, on the anode business, we have developed some technology that uses this existing vapor deposition technology. Most people would recognize the product of a chip bag, and so that metallic layer on the chip bag is formed through vapor deposition. So Mustang Vacuum Systems is a SME based in Florida, privately held, that has been making vapor deposition machines for some time. And so by partnering with them, we can bring our anode product knowledge, but also some IP that we have developed to really adapt that technology for the purpose of lithium deposition onto substrates like copper. And so we're working through the definitive agreements now, and part of that deal is also that MVS or Mustang will become a strategic shareholder in Li-Metal, as we conclude that deal. So just piggybacking off the highlights, that's another recent milestone from the company. But taking a step back, why is all this important? Lithium-ion batteries are being scaled up across North America, across Europe. Everyone's talking about lithium, nickel, cobalt supply chain. But this technology is obviously improved, but invented in the 90s and has helped drive electric vehicles forward. However, looking at the next wave of growth to achieve better performance, a new technology is needed, and that's what we call next generation batteries. This could be solid state, this could be lithium sulfur, this could even just be liquid electrolyte with the new anode or lithium metal anode. And what that does is really allows us to get into higher energy densities, so smaller footprint for the same range, higher specific energies, lowering the mass, which especially in the electric air mobility space is important, and then improve safety, moving from the liquid to solid electrolyte helps improve safety, but that needs a better solution on the anode side. And so we see, major OEMs committing to this either through their own R&D or partnerships. Majority of the OEMs on here are leveraging other people's technology in terms of lithium-ion batteries as the replacement to the engine. That's a big shift for automotive companies, but the engine's always been a part of the heart of the vehicle and the heart of technology in an automotive company. And now you shift to using somebody else's battery, it's not really the end goal. And I think that that's where next generation batteries come in, that having a opportunity to have different battery types and performance will be a key part of differentiating EVs in the future. So why did the company enter this market? The founders, Mache and Tim, who sits on our board, saw this opportunity that metal-based anodes are going to come. Right now, globally, there's a very relatively small production of lithium metal, only about 3,000 tons produced at a battery grade, and most of the capacity is in China. So this goes counter to the whole thought process around domesticating supply chains for the battery industry. You see on the graph, the demand is going to go up significantly. So there's a need in North America and in Europe eventually for these new battery types that are being developed today to establish metal production and even anode production eventually. And just to highlight again why the anodes, so you kind of pictorially get the fact here, but right now in the lithium ion cell graphite, the anode is about 40% of the weight. Lithium metal is about 10% of the weight in a battery. By doing that, that allows you to put way more cathode material into the same weight battery, which creates the effect of greater density, and thus more kilowatt hours per mass. So what problem are we really trying to solve? I talked about domestic supply chain. So right now, outside of China, there's a very small production of metal, and really nobody looking to expand that. On the anode side, primary batteries or your coin cells, use lithium metal anodes. They use it in a process where they roll the metal out into a thick sheet. That has its limitations on how thin you can go, how wide you can go. And if you use those thick sheets in a next generation battery, the cost will be prohibitive. So it's not really suitable for mass market. Mentioned the high cost of production, and processes aren't scalable. Currently, metal is made from lithium chloride. That's not an easily permittable process to use chloride in metal, because you end up with a lot of chlorine byproduct, and from a sustainability perspective, also difficult to scale. So we really see that Li-Metal sits in a position where others aren't tackling. Others may be doing chemicals to metal production and maybe rolling foils. Some people are focused only on the foil side, but we feel we have some advantages on the thin anode production. So just to dive deeper, I talked about it a little bit. Our lithium metal process takes lithium carbonate, which growing feedstock availability, and uses molten salt electrolysis to really separate the lithium from the rest. We produce a technical grade lithium that can be then refined into a battery grade ingot, which is the final form. We see this as a lower cost, lower environmental footprint, and obviously continue to protect various parts of the process through our patent applications. Here pictorially, you see what vapor deposition is. So basically, you have a roll of copper going through a chamber, vacuum chamber, where lithium is evaporated onto the copper. So rather than rolling out to get thinner and thinner, you're basically building that base layer of lithium. So instead of a 60, 70 micron lithium layer, you can actually get a 5 or 10 micron layer lithium product. And so then the base product is really to use copper, but we're looking at different substrates that can continue to help reduce that mass, particularly for electric aviation. So left to right here, you see our pilot facility in Rochester, New York. That's the roll of lithium on copper coming out of the machine. Here in Toronto, in our headquarters, we on the right side actually have our lithium metal pilot. And then we also have what we call our advanced anode lab, where we can analyze the material, build cells, check performance, and also try new materials here at home. So where are we going? We see that the groups that will want lithium metal anodes and want to produce them at scale will need lithium metal, and that's where our vertical integration comes. That said, lithium metal has an existing market, not only in primary batteries, but alloys and pharma. So as we continue to demonstrate continuous metal production, we're looking to scale that up to a commercial level in the next 2 to 3 years. That could serve an existing market, but also start to feed our anode business, which is really dependent on our customers, the battery developers, on how fast they can scale and deploy and qualify their technology. So right now from Rochester, we do send materials out. We're starting to get larger and larger orders, and eventually we'll need to continue to scale lockstep with our customers, our capacity to meet their demands as they meet their customers' demands, which are the mobility companies. So just to dive deeper into that for those that don't know, I mean, the next generation batteries and companies we work with are rarely in this left side, pre-A sample, small batch, really trying to get the formulation right of materials they'll use in the production. But it takes several years to get these into products. So while people may say, oh, solid state's going to be end of the decade in the vehicle, the work's being done now to really lock in that design, and by the time you get to a B sample of 2-3 years of development, the suppliers of key materials and processes have been locked in. So our business development right now is to start to get those materials into the hands of the customers with steadily increasing quantities, so that we can lock in. And though they may not be commercially relevant for 5 years and selling large quantities, there's an ability then to start scaling our production and earn revenue in those sampling years for the material. And talking about customers, we've active conversations with 27 plus automotive and battery OEMs. There's about 13 companies right now sampling the material, giving us feedback, iterating on what they want to do. So, I mean, we are developing our products and technologies in parallel with, our customers are also in the midst of developing those technologies. So looking forward, as I said, we're listed about a $50 million Canadian market cap. End of last year, we had about $14 million in cash. There's an insider ownership of about 25%. Our goal right now is to continue to advance the engineering and the R&D of both programs and continue to, with my team, grow strategic and commercial partnerships like the one with Mustang, and build the order book to start deploying more material in the future. And with that, I think I'm ahead of time, but that leaves us more time for any Q&A that we may have. So, there's a question about IP portfolio. As I mentioned, we have 33 patents filed. This development's been ongoing for some time, and a lot of that application's been done in the recent months and years. So they're still all in progress at the moment. In terms of end of year milestones to end 2023, on the metal side, we continue to pilot and try to achieve continuous lithium production. We've been doing some of the engineering, which was previously announced, to scope out what's the cost and timeline to build a commercial facility. And on the anode side, locking in the Mustang partnership will help us to look and ascertain demand for groups who are interested in making anode on-site or off-site. In terms of capital needs, as we finish the engineering study, that will help us dictate what do we need to build a metal plant. We don't have any numbers that we put out in the market yet, but that will dictate how we move forward with our capital planning. On the anode side, to build additional capacity, we will need additional capital, but also that would be built out once we have additional demand in a more binding manner. And we have the capital we need right now to continue current pace of operation and development. But in light of the things I just said, obviously, as we want to grow and get closer to commercial, there'll be additional capital requirements. There's a question on timeline to move from pilot to production. As I said, we have to finish the engineering study. We're doing some additional testing, and it'll be 2 to 3 years on the metal side before we get to full production. The anode could happen faster, but it's really dependent on external timelines and demand criteria for our customers to be qualifying their material with their customers. Great. So far, nothing else in the question queue. I can hang around for another minute or two in case there's additional questions that people think of. Else, I want to thank everybody from the audience for attending. And, as the moderator, Bob, mentioned, if there's more information needed or a deep dive, our contact info is there, or we are happy to schedule one-on-ones with groups that are interested in learning more.